Okay, let's try cos to the negative 1, or arc cos, or a cos. How am I going to define arc cos? Think about a cos graph. No, that was a sine graph. Times BM. So again, if I flip that, it's not going to pass the vertical line test. I only need a piece of that graph. Which piece do we use for arc cos? How do we work it out for sine?
Well, you got to find one that doesn't have two overlapping bits. Should start from the origin and go to -1. So 1 to -1.
This bit won't work.
No, that won't. That's what I said. 1. Oh, when y equals 1 and y equals -1 after the origin.
Here.
Yeah.
Correct. Arc cos, and you can test that. Ask your calculator for cos to the negative. No, hang on. Cos to the -1 of. How do I help you see this? Cos -1 of a half should give us 60 degrees. What's cos to the -1 of -a half? What's cos to the -1 of? Yeah, let's ask it for that. That's actually probably enough. What's it going to tell us? 120. So it is indeed using this part of the graph, second quadrant. So my arc cos goes there. Origin up to. That's not right.
That's not right.
That's not right. I can't draw it right. Here. That's better. This one is 1, 0, because 0, 1. And this one is
-1 pi.
-1 pi, correct. And this point here is 0 pi on 2. Let me ask you for sine to the -1 of 1 on root 2.
What the chisel do?
Sorry?
40.
200.
No, it's fine.
In radians?
In radians, please. What do you think it is?
What do you mean?
What angle has a sine value of 1 on root 2?
45.
Or pi on 4. Still getting used to these chisel nibs.
Yeah, that's what I was dissing earlier.
I know. What is cos to -1 of negative root 3 on 2? It's tricky.
Root 3
You know which triangle we're talking about? 1, 2, root 3. Root 3 on 2 is cos, so it's pi on 6. However, negative, so I'm in the second quadrant. Arc cos is defined for the second and first quadrants. Whereas arc sine is defined for the first and fourth quadrants. So, second quadrant, pi on 6, so it's actually 5 pi on 6. Actually, if you have the CAS TI calculator, it'll probably give you 5 pi on 6 if you're in radians, rather than a decimal. I don't know what yours gives you, Rain.
Should I try?
I'm guessing a decimal. Ask it. I'm guessing it gives you a decimal. I think you guys might be clever enough to tell you that is
Yes, they are.
5 pi on 6. They are.
I used it in the methods. That's
Did you see it? Did you see him do the special stuff?
No,
Never mind. You should ask us to look.
I'll have a look. What is sine to the minus 1 of, let's do the same, negative root 3 on 2. Root 3 on 2 is going to be pi on 3, but it's negative. I want the fourth quadrant. Negative pi on 3. Sine of arcsine of a half.
Half.
Why?
Because cancel each other out.
Be careful. What if I ask you for,
Wait, so is it a half?
I'm not giving you an answer just yet. I want you to think about this one. What do you think that one is? Because I can tell you for sure the answer to this is not 5 pi on 6.
It's going to be pi on 6.
Why?
Because I did the arithmetic.
No, you have to be able to explain this. So,
How the hell did you do it?
Because sine of
it's because of the domain and range, right? That's why it's important to know how these are defined. Sine of, well, arcsine of a half is going to give me an angle. Do you know what angle that is? Correct. And sine of pi on 6 is indeed a half. But this one is arcsine of. Now, sine of 5 pi on 6, where's my thing? Sine of 5 pi on 6 is the same value as sine of pi on 6. It's a half. But the arcsine of a half is pi on 6.
So I could do that, I just didn't know why.
Hint, certainly for Rayan, probably for you, I usually put a question like this on the exam. One of these. See if you're paying attention and know what you're doing. Could be a cos. Okay, what haven't we looked at? Tan. 10 to the minus 1 of x, or arctan of x, or a10 of x. You've got to get used to all of them.
Can you do the reciprocal of the...
It's not, no, you don't want to do the reciprocal.
I would say can you?
You don't want to. Again, what we're going to do is look at a tan graph. What does a tan graph look like? That's the funny one, right?
The graph's going to have...
So we're only going to look at the centre section. So arctan does this. With two horizontal asymptotes. It goes through the origin. What are these asymptotes up here? Pi on 2, negative pi on 2. So this one is pi on 2, and this one is negative pi on 2. Hunting around for colours. Why? So the range of arctan is negative pi on 2 to pi on 2. But the domain is anything. Because tan has a range that's anything. So swapping domain and range. And that's arctan. First quadrant, fourth quadrant, or positive angles, negative angles. So for example, 10 to the negative 1 of 1. Shh. See if Ryan can tell me.
Is it based on the graph?
Yep, sure. What's the y value when x is 1?
I don't know.
Yes, you do. What angle has a tan of 1?
Is it pi on 4?
Yep. Let's go negative 1 on root 2. That's not right. I don't want that. I don't want that. I want 1 on root 3. Always get this wrong. 1 on root 3. Well, that's a 1, 2, root 3 triangle. 1 on root 3, opposite on adjacent, so this is my angle, pi on 6. It's negative, so I'm the negative angle.